And welcome to our Survey Like a Pro webinar series. In this series of webinars, we'll follow your data from the point of capture through verification and correction, running reports in Survey Manager and PCS, and ultimately exporting and sharing your data with other systems. The final session in the series will be a live presentation at our users group in Austin, Texas in October. In this first session, we'll cover tips and tricks to conduct accurate close interval surveys every time. We'll send a link to this presentation in a few days so you can refer to it at any time or send it to a colleague who may have missed it. To register for the next 3 sessions, just head to our website, aiworldwide.com. If you attend all 4 sessions, including the one at Users Group, we'll send you an American Innovations hat. I'm David Gaucher, Product Manager at American Innovations. I'm joined by Technical Support Tier 2 team member Lon Duke. Lon has been with American Innovations for over 14 years, is a CP2 and a resident Allegro expert. First, a little housekeeping. Please submit any questions you may have using the questions panel, and we'll answer them at the end. If we don't get to your questions, we'll send the response via email after the presentation's over. Without further ado, I'll hand the presentation over to Lon.
Good morning. So what we're going to do is we're going to go through close interval survey on the Allegro. We're going to look at several items during this presentation. We're going to look at some of the pre-assessment survey setups. We'll go through some of the features in CI that will help you get a accurate and good survey with as much data as you can get. It's very important for gathering as much data as you can to be analyzed at a later date. We'll also look at some test point information screens, and I'll give you an example of what the Reconnect would do. So what is CIS? This should be pretty commonly known, but it basically gives you an overall health of your CP system along the entire pipeline. You're looking for lower spots, any anomalies, odd behavior. You are using a trailing wire, so this is a pipe to soil along the line, minus your IR error. So let's talk a little bit about pre-assessment. NACE SBO 502 calls out a lot of pre-assessment items. These are just a few that we'll highlight here. Pipe data. What's the coating of this pipe? What's the size? What's the age? Coating affects a lot of things. Size will do. Age. Is this a 1950s pipe, 70s, 80s? Is this a brand new FBE coated pipe that's just been put in the ground? Soil and row condition. So what is that right of way like? Is it well maintained? Is this going through residential area, commercial area? Are we going to have to cross roads? What's the soil resistivity? This is something that's vastly different whether you're surveying out in West Texas or you're surveying down in Louisiana. Can really affect the CP system and how it's tuned. What's the depth of cover along this line? And we'll talk a little bit about recording, the easy way to record depth of cover later on. The CP system that's on this line, rectifiers. How many rectifiers are out there on this line? If we're going to interrupt it, we'll need to know, do these rectifiers have bullhorn or some remote monitor on there that we can set up a schedule to interrupt so we can do an interrupted survey? Or are they capable of turning the rectifiers off for a certain amount of time so we can do a depot survey? Ground bed types. Are there galvanic anodes on this line? That can drastically affect the CP system? Do we need to disconnect those? These are things we need to know ahead of time, if possible, know where they are and how they're going to react. Operational data on the line is something that would be really good to have. If you can get it, what's the construction history on this line? Have sections been replaced and where? Has a tie-in been here recently? What are the historical readings? If you can get past surveys to get a better idea of how this line plays out as far as its CP system, so that you are aware of possible areas that, yes, this is a bad area that the company or client knows about, so you're not having to stop your survey to try and get in touch with them to get some more information on it. Everything you can get ahead of time is best. The more, the better. So for the Allegro, what is our pre-assessment for the survey itself? Are we going to do flag mode or fixed increment? They are quite different. If we're doing fixed increment, what increment are we running? Is this going to be an on-survey? On-survey can be an on-survey, or it can be a native or a dipole type survey. Or is this going to be an interrupted survey? Are we doing an AC or a DC CI survey? The Allegro will do either one. Is there any AC mitigation on this line? This is pretty important. AC mitigation on a line will really affect interrupted CP surveys. It really causes a lot of curve if you're looking at your waveform, and can be very, very tough to dial in. Are we going to need sub-meter GPS? Is that required on this? This is something that we need to get set up ahead of time, make sure we can connect and record our sub-meter GPS coordinates for each of these readings. What kind of notes are we going to need for this line? Notes can include pipe exposures, PIs, what's the depth of cover. You're going to want to record as much as you can as far as notes. If there's a washout there, record that. Some sort of any other type of exposed pipe. Again, the more data you collect, the better your survey is going to be. CI equipment. Do we have the right equipment, and is everything set up correctly? Reference cell. Do we have the type that we need for the area we're going to be in? Has it been cleaned recently? Is it charged? Something in here as far as having your reference cells charged, or they charge at the same time. Is there a difference between the two reference cells? If you have one good reference cell that's just been cleaned and charged, and you have another reference cell that has been contaminated, you can have a 30 to 40 millivolt difference between the two cells. Can really affect your survey as you're going down the line. DVM, is your DVM calibrated? We do that service here at AI. We'll give you an annual certificate of calibration. Is your Allegro charged? If you're using a QX, that has a very good battery life on that one. Make sure the MX, if you're running an MX, it's charged and you have a spare battery. It's older technology power on that. Wire and cabling. Verify all your continuity, all your connections before you get out there. This is important. You don't want to be setting up your survey ready to go, and now you've got a broken wire that you need to stop and fix or troubleshoot. Get all this stuff set up ahead of time if you can, and carry spares. Any type of spares you can have, carry them with you. This is a little bit of information about the current release of the Allegro applications. We are on 712. I would highly recommend that you get up to our latest 712. If you look in your view menu in CI at the About, it should look like this. You should have a 712 build. You should have a USB version of 7.0.0. That's pretty important. This is where you can see your DVM model number, and it also gives you the serial number of it, and it gives you the calibration date. So this is something to look at ahead of time. All right, so setting up the Allegro, like I said, there's two different modes here that we are going to be using. There's a flag mode and there's a fixed increment mode. Flag mode, you're going to be using the buttons on the data probes to record your readings. So every time you hit the button, that's when it's going to record the reading. With fixed increment, you're able to use the wire counter in the chainer or the hip pack or the backpack that you have to increment as it pulls out so many feet of wire. And if you're using this, they need to be in 2.5 foot increments, 2.5, 5, 7.5 foot increments. It knows what 2.5 foot increment is on that spooler, and it will trigger reads. So a couple of subtle differences here. One, the remote trigger is going to be going directly to the survey probes in flag mode. In fixed increment, that remote trigger is going to come from your wire counter. Spools, we offer spools here, and we have sleeves for these spools. You get a spool like this with a sleeve on there that's shown, leave it on there. This drastically reduces any type of fly out of the wire. Saves you a lot of time on having a break and having to stop and reconnect and get back to where you were. These are great. We can provide these for you if you don't have them. Any other type of accessories, feel free to contact us. We have all the accessories for doing all of your CI surveys. There's many of these that are on our online store. So if you want to get on there and browse, that's probably the easiest way to do it. Or you can give us a shout here and talk to sales about what you might need for your CI surveys or spares, extra cabling, anything like that. Okay, so after we have everything done, everything I've talked about so far is before we even get out to where we're going to start our survey. So I can't stress the importance of this right here enough. When you get out, if you're doing an interrupted survey, the very first thing you need to do is hook up to that pipe, open up the AI DVM application, set whatever you need for your interrupted survey to match your interrupters. Verify it. So once you have that set in your AI DVM and the on-off options, you're going to open up your graph. And you're going to look at the graph and make sure you're taking your on and your off exactly where it needs to be. And you are in sync and you're locked in. Looking at the waveform is something that is really, really important. I can't stress that enough. Get to know these waveforms. Know what you're looking at. You will see some very, very different things if you look at these waveforms on different lines. I mentioned earlier AC mitigation will drastically curve these lines. I've seen zinc ribbons that really flatten things out. You can see interference. You can see if you have a rectifier or as I should say, an interrupter on a rectifier that's out of sync with the other ones, it will show up here. I will be talking about waveforms at our user group. So we'll be doing a seminar on some of that, looking at different waveforms, troubleshooting. Please attend if you can. It'd be great to see you there. Okay, so in the application itself, let's just kind of make sure that we know what everything is here. Up at the top, there is a survey graph. Now, you can shut this off if you'd like, and I'll show you that towards the end of this. But it just gives you kind of the history as you're walking along doing your survey. You can start to see if you're trending down or trending up, or if you've got a spike. Stationing is that first column. This stationing is if you have your fixed increment set to 2.5 feet, it's going to increment every 2.5 feet or every 5 feet, whatever you have that set to. If you have set to flag mode is going to increment one at a time. So it's going to increment by 1 until you close a flag, and then it's going to rubber band back to the last flag. We have a marker field in there. That's where you will see your flags. If you add a manual entry, which I'll show you here in a little bit, it'll have an M in there. The third column over is going to be our on pipe to soil. If we're doing interrupted, we will have an off as well. We'll look at a little bit more of these, the differences in the modes here in a little while. And then we have a remarks column. This can be typed in, or we can use the remarks function to add remarks quickly. We have all of our live readings at the bottom. The first one's the on, the second one's the off, and these are the current on and off for your cycle. The third one is a live reading. You'll see this one just fluctuate. It'll go up and down. And then the next one where it says off, that's where it is in the cycle. That'll switch back and forth between on and off. And then down the corner, you'll see either a G or a D or a 0, and it'll be red. 0 and it's red means we are not getting any type of GPS. If you see a G, we are getting GPS. If you're getting differentially corrected GPS, then you will see that D there. Okay, so the first thing we will do is we will be setting up all of our survey settings ahead of time. So we are going to go under the File menu, and we're going to go to Properties. And the first thing in Properties is the Survey tab. In the Survey tab here, we have Segment. Now, if you know what the right-of-way is, the row code, or whatever you have that named in PCS, this segment needs to match that code. Just everything up to the code, you don't have to worry about the name in there. So it needs to match that so it knows where to put it in PCS. If you have a parallel pipe, for instance, this one has a 6 and a 12, you can put that in there. If you do not have a parallel pipe, just leave that blank. Don't worry about it. Technician, put in your name in here, and then the run. So the run is kind of where we're stopping and starting for this particular survey. So we are doing this section of the survey, and we want to know it's starting here and it's ending here. Or if you know the stationing starting and end, if you're at a landmark or something about this. It could be, this is a survey through a park or through a business district. Something there that you know what this survey has in it. The run is what is going to be the name of that survey in PCS when you bring it into PCS. So make sure you fill that out and it's descriptive. And make sure it's unique. If you're doing another one, change that name. So it'll be a unique name. All right, so the next tab is the type. Like I mentioned earlier, we can do DC, which is the norm. That's the most common. But we can do AC surveys if you've got a right-of-way that's under an HVAC corridor. Then you may be out there doing a AC pipe to soil. We can handle either one of those. All right, we talked a little bit earlier. I'm going to talk a little bit about flag mode and fixed increment. So flag mode, the first thing we'll do when we're setting up flag mode is we will measure, in this particular instance, we have a flag distance of 100 feet. So what we'll need to do is go out there and mark off on this pipe 100 feet. We can put a flag there, we can put a paint marker there, anything that lets us know that we are at 100 feet along that pipeline. So that when we are walking along the line, as we put in flags, it's going to know, okay, I've gone 100 feet from the last flag to the one that you just put in. And what that will do is that will rubber band your stationing to fit within that 100 feet. For instance, if I take 40 reads in 100 feet and I have an open and a closed flag, it's going to set that to 2.5 feet. It's just going to rubber band it to 2.5 feet. If I did 20, it's going to rubber band it to 5 foot for every reading. It's pretty accurate. Direction, descending or ascending. Take a look at this. I want you to be aware, descending, if it's set to descending, it will not go past a 0 stationing. I've had calls on that where they're trying to take readings out in the field, nothing's happening, and they're at 0 and it's not doing anything. It's at descending, it's not going any further. So set it to ascending, or if you need to go descending, which you can go further down the line to a certain test point, certain stationing, and you can come back up the line. Just make sure you have enough room there. You can do timed readings on this, up to 90 per minute. This is used to drag a reference cell maybe across a river. As you go along there, you can set the timed readings and just let it take a reading every second across there if you need to. You can monitor your flag count here, which is kind of nice. You can set it to a certain percentage, so if you go past what you normally, the normal number of readings that you've been doing with your flags, it will beep and kind of give you a warning, say, hey, you might have missed a flag, so you might need to go back and take a look at that. Now, fixed increment mode. Fixed increment, where you're going to tell it, this is how far we are going in between our reads. The direction, same thing, ascending or descending. And this, normally you'll use the wire counter. The wire counter knows what 2.5 feet is. So as long as you have increments of 2.5 feet, as it pulls out 2.5 or 5 or 7.5 feet, it's going to trigger a read to be recorded on the Allegro. You can shut the wire counter off and have it increment every time you hit the button on the Allegro. It's going to increment by this amount. So you can use either way on that.
Yeah, so you talked about fixed increment line and flag mode as well, but are there any pros and cons between using the two? Is one better than the other? Are there use cases where one might be preferable?
Well, the difference between the two, there's some debate on which one you'd like to use. Flag mode is resetting your stationing every 100 feet. It's pretty accurate. You know when you get to the end of that line that your distance is pretty accurate that you picked up, because every 100 feet you're resetting that distance. You know you've gone 100 foot. It takes more setup ahead of time. So that is one caveat to it. It takes some extra setup, but it is, to me, more accurate or easier to get that better accuracy. Using the wire counter is easier. You don't have to do that pre-setup. However, you've got to be very cautious on there. If you've got a PI and you're veering off now what your normal right-of-way is, it's curving off, we need to make sure we anchor that line down so the distance is correct. If you go down a hill and back up, we need to make sure we anchor that at the bottom of the hill so that that wire isn't coming up and our accuracy is going to be as accurate as it can. So it's really your preference of what you want to do. If you'd ever like to have debates over which one, give us a call. I'll be glad to talk to you about them. All right, so as far as the on-off goes, or types of surveys we're going to do, the first type would be just an on single read survey. Now, this is just doing an on survey or a D pole. This is the simple one. Everything's disabled. There's nothing to set on it. If you are running this survey, you are seeing a single column. That's all you get. So like I said, it's pretty simple. Then the next one would be a HighLow. HighLow is used if a couple of reasons. If you do not have interrupters that are GPS syncable, which most of them are these days, or if you're in an area where you can't get GPS, because the GPS sync goes off of satellite timing, you can run this in HighLow. HighLow just basically looks at your entire cycle. Like in this one, it's 3 and 1. It's constantly looking at 4 seconds and sorting them out and throwing out the highs and the lows to get the most accurate on-off that it can. Caveat to this is it will always assume that the more negative is the on portion of the cycle. And you will see the high-low down there at the bottom. GPS sync, of course, GPS sync, this is used if you're doing your on-off surveys. On-off surveys are going to be using a satellite pulse to keep everything in sync with the same pulse that the interrupters are seeing. And so this has a few more settings on it. I showed those earlier on, with the waveform. And you're going to see both your on and your off columns if you're doing GPS sync. If you fall back, if you lose satellites, then it will fall back to the high-low mode. So be aware of that. If you can ahead of time, try and get your high-low mode dialed in to as close as your GPS sync, then you shouldn't have to worry about it falling back to high-low. GPS real-time. Now, GPS real-time is slightly different. I'm going to go to the next slide. The settings on this are a little bit different. You're creating windows. If you see the little gray areas at the bottom, you are creating windows there where you will not take a reading. So if you've got a longer cycle, you can use this because it's only going to update every time that cycle comes around. So if you're doing an 8-second on, 2-second off cycle, you're only going to get a new on-off reading every 10 seconds if you're in GPS sync. In GPS real time, every time you hit the button or it triggers a read, wherever it is in that waveform, it's going to take that reading. So you're basically just telling it, I'm not going to take a reading during the transitions. And if you're looking at this in the survey, you will have a column where you will have your on. So it's only taking, that's only part it's seeing is in the on, and then you'll take the reading in the off. And that's all you'll see. So it'll switch back and forth. Then the last thing is GPS. record GPS every reading, record time of reading. Why not? It doesn't cost you anything. It doesn't drain your battery any. It's there. Post it. It doesn't cost you anything. Why not use it? And then there's a message there, of course, you can show. It'll pop up if you lose GPS. Save your file. This is very important here. So once you have all your settings and you're ready to start your survey, save that file. Save it, and then you can use your autosave function to save it every 10, 15, 20, 30 minutes. If you don't save it ahead of time, it doesn't know where to save that file or what to save it as. So save the file. Save your data. I can't stress that enough either. All right, so when we start off our survey, one thing that we can do is tell it we want to go to a certain stationing, a certain milepost, a certain distance, and we can put in there our milepost. So under the move, you can do a go to, and you can put in your stationing you're starting at. It will put an M in that marker column. It also uses that M as its first flag if you're using flag mode. So you don't have to worry about putting a flag in there. It's going to use that. If you are doing flag mode and you come across an obstacle, a road, a river, or something that you can't survey across, you can use gap. So what you'll do is you come up to the edge of that, you will put a G in. It's going to rubber band your stationing from that G that you just put in back to the last flag that it saw. And it's going to use the increment, the average increment that you've been getting for like the last 3 flags. So once you get to the other side of that obstacle, you will put in another G, and that puts in a smaller or lowercase g in that marker field. And then you continue surveying till you get to your next flag. When you get to that next flag and you put in a flag, it's going to increment that stationing or rubber band it from that flag back to the little g. So now we still have 100 foot between our flags minus the gap. If you are using fixed increment and you are using the hit pack to trigger your reads, then you will use skip lock normal if you need to go around something. Skip is still going to increment your stationing. So if I need to cross a road or something that I cannot survey, or I need to come back and drill and survey, you can use the skip. It'll still increment your stationing as you go across the road, but it's going to put skip in the remarks so you don't have to worry about the reads. It'll let you know these are bogus reads. You get to the other side, you can put it back into normal. If you put it in lock mode, then as you pull out the wire, it's going to ignore it. So if you need to move around something, get to the other side of it, you don't want to break your wire yet, you can. Another thing to use is the remarks list. Now I talked earlier about figuring out what you need to use for notes. This can help you out quite a bit. So in the remarks list, if you bring that up, you can either hit the F4 on the Allegro, or just tap the remarks in the menus at the bottom. It will bring up this window here. So like on this particular one, all I have to do is type in 09 and it puts in aerial marker. I don't have to type it out every time. It's a quick and easy way to do this. And it will put aerial marker in there with in my remarks field. You can customize this. So this is in the AI CI data folder. It's just a text file. You can open it up in Word Mobile if you'd like. And you can come in here and customize it. For instance, in this particular one, we customized depth of cover. So I knew ahead of time Our depth of cover was between 24 and 30 on the segment we were doing. I can come in here and set my 24 through 30 or beyond to DOC and that depth of cover. So now when I am walking along, I can come into my remarks field and I can just type in 26 and it's going to put in DOC 26 into my remarks. So it's a handy way to use your remarks list. Other than that, any other type of remarks that you're going to use quite a bit, again, know what you're getting ahead of time. You can customize this and move those up to the top of that list. So your 01, 02, 03 are right there. You know what they are. This is just a really good shortcut for these. Okay, I talked a little bit about the graph earlier. So you can use this graph if you want to see the trends. Like on this particular one, we saw where it trended down, we saw where it trended up. So as you're walking along, this will keep kind of a history up to the point that you're collecting your readings. You can use this or not. It's nice to have up there. However, it does take up about 3 rows of data. So you can turn this off. All you really need to do is simply tap on the graph and it will bring up a window and you can disable that. You can say, I don't want to show this. You can also set your upper and lower value and the width of that graph. You can set that to 500 feet if you wanted. Your upper and lower value or the voltage readings that you're seeing. Another good thing to use is test point information screens. This will allow you to collect data on a lot of different facilities along that line. Again, the more data you can collect for a survey, the better. So we can analyze this after that survey is done. The survey is a lot of work, but there's also a lot of work afterwards. So the more data that you have to analyze this, the better. So in test point information screens, some of the items here, these are the items that we provide for a test point information. Single test station, we've got crossings without or with a bond, line casing. There's everything in here, rectifiers, if you need to collect an AC potential. Anything that you need to collect along here, if you come across a test point or rectifier, if there's a bond there, if you need to do a side drain, collect a side drain real quick, collect a side drain. This is an easy way to do it. A shortcut to this, of course, is Control-T. It'll bring up the list. If you select one like a Reconnect, should be pretty common as far as probably the one you may be using the most. Reconnect is every time you come up to a test point, you're going to want to reconnect your wire. So you're going to want to reconnect that wire to that test point, roll up the wire that you had from back to the last test point. And so for a reconnect, what we're going to do is we're going to collect our far ground on and off if we're doing an interrupted survey. And then we are going to look at hook up between the test points. So we leave that trailing wire hooked up and then hook the other side of the DVM up to the test point that we're at and get our metal IR drop, which is basically our error from that test point down to this test point. How much are we losing there? And then we're going to get a near ground or a pipe to soil right there at that test point. And this is all very, very good data. It's good stuff to see. Once that's collected, everything is going to go into your remarks. which is really good. You can parse all of this out. They're in a pretty standard form. So that's data that you can parse out later on and collect. If you need to do any other analysis on it, it's good stuff to have. All right, just to recap on a few things here. Again, gather as much data as you can beforehand. It will save you time, save you money. The more data you can get, the more information that you can get about that line, that right of way, what you need, the better. If you're doing an interrupted survey, please make sure you get to know those waveforms. Those waveforms are very important. You can see if you're dialed in or not. Do I need to make adjustments on this to move my off delay out to get a better instant off reading? Is it out too far because I've got a lot of dipole and now I'm getting a much more positive reading than my actual instant off? Get these dialed in. Save before you start your survey. Save that file. That's really important. You don't want to lose data. Save the file. Use your save functionality, auto save functionality, to make sure you don't lose any data and have to backtrack and resurvey. If you have any questions, you can email us or you can give us a shout. Our tech support will be more than happy to talk to you. Again, come to our user group. If you have questions about any of this, we will sit down and discuss them with you. Again, I'll be talking about waveforms there. If you have any questions on that, we can sit down and talk about that as well.
Thanks, Lon. That was awesome information. We'll open the floor to questions now. So just use the questions panel in that GoToWebinar window and just type in your questions. We'll give you guys and gals about a minute to finish submitting your questions and we'll answer them. Okay, we have a couple questions here. One's from Todd asking about when you start a survey, you're putting in your station where you start, right? So what happens if you're starting at a milepost? 245.5 is the example when you're doing a descending. How do you indicate that?
So it'll be the same thing. You just put in your number. It's going to automatically format in that stationing format. So that milepost will become your stationing. The number won't change. and then you'll be able to use that going forward with your mileposts, with your stationing increments.
So in that case, if they give you a milepost, then you would need to convert it to feet.
Feet plus.
Feet
Correct.
plus, and then that's how you would get it to that station.
Yeah.
Okay. Next question from Chris. How do I connect a sub-meter GPS for better accuracy?
Okay, so we carry a couple of sub-meter GPSs here that we resell. One is a Trimble, one is a Juniper Systems. These are connected via Bluetooth. So on your Allegro, you will have a utility in there. It's called Bluetooth COM. I would recommend that you use that. You'll connect this up via Bluetooth. There are some settings that you may need to do depending on which GPS module you have. There are some utilities that go with these external GPSs that you can set different things on there, such as what virtual port am I putting this out on, what NMEA settings am I putting out on this port. But you'll connect these via Bluetooth. It'll assign a virtual COM port to it. And then in your properties, when you're doing your survey, you will set it to that COM port. And then it's going to use that external strictly for your coordinates. It will always use the internal GPS on the Allegro for its timing pulse for the interrupted surveys.
Yeah, and that timing pulse again ties back to if you can use GPS sync or GPS real time, or if it needs to fall back to high-low.
Correct.
That kind of goes back to what you were saying earlier about making sure your high-low settings are set up exactly like your GPS sync settings, so that if it does fall back after 10 minutes, then you can just continue to do your survey until you regain that time pulse from your GPS.
Yes. So setting up those high-low settings to match your GPS sync settings is what you'll have to keep playing with those until you're on and you're off. If you switch back and forth between GPS sync and high-low, those on and off numbers are the same, or pretty close to the same. Your settings on there can be vastly different as far as your on and off delays on those for high-low versus GPS sync.
Great. It looks like that's all the questions we have. That's going to wrap up this webinar. Thanks everybody for joining. Be sure to come back and join us in August for the next installment of the series, where we're going to follow the data from the Allegro to Survey Manager so you can collaborate and verify the data before committing it to your database record. Thanks and have a great day.